Hey everyone, this is part one in the series of Getting Practical with TypeScript. We're going to cover basic TypeScript functionality, and then we're going to basically put it all together with a project that we're going to create with TypeScript. The aim for this project, like it says in the title, is Getting Practical with TypeScript, is to actually teach you the basics of TypeScript and then actually getting practical with it. A lot of tutorials and courses make the mistake, in my opinion, of just showing you individual components of a topic, not necessarily TypeScript, but any topic, and they never actually show you how to put it together with a project. So that's what I'm going to be doing here. So we'll be starting off with the basic types and then maybe slightly more advanced functionality, but then we'll get into a real-world project. Okay, so first of all, TypeScript is a layer on top of JavaScript which adds static typing to JavaScript. So what do I mean by that? If we look at a regular JavaScript file and we say let name is equal to Jacob, we can say on the next line name equals 10, right? Which can lead to problems. Let's just change this to username since VS Code isn't happy with name. And this is obviously a problem. I mean, we start off as a string, we make it a number. The same thing is if you, let's say for example, say function sum, and you have a and b, and you want to return a plus b. So there's nothing stopping you from going like hello, right? And this is completely nonsensical. It doesn't actually make any sense with regards, and you don't really get so much usefulness out of your code editor. You have no idea what you're supposed to be passing through. You have no idea what type, and don't get me started as if this is even a more complex object like function do something which receives an object, right? So when you say do something, you have no idea what to pass into here. An object, does it have a name? Does it have, who knows what it has on it? And that's where TypeScript comes in to help us. It's by adding static types to each variable and each piece of data in our application, and it allows us to explicitly declare its type. So jumping right into things, let's just clear this out and do npm init-y. And let's also install TypeScript in development mode as well as tsnode. And tsnode is just a wrapper around Node which compiles our TypeScript files into JavaScript before it runs it. Once that is done, let's also go npx tsc --init, and this is a way of initializing a TypeScript project within our npm project, and it creates this tsconfig.json. Right now it's complaining because there are no TypeScript files in the project, so we'll fix that by just changing this to index.ts. Cool. Now that we have that done, let's start off with declaring some basic types. So just like in JavaScript, where we have age, where we have numbers, we have username, which is Jacob, and then we have let is developer equals true. So these are three very basic types. We have a number, we have a string, and we have a Boolean. So if we look and hover over each one of these, you'll see that we're able to infer by the variable assignment that this is indeed a number, as well as over here this is a string, and this is a Boolean. So if we go like this, username equals 10, you'll see it'll complain because the type number is not assignable to type string. So this already solves a whole host of problems for us. And those are the basic types. So if we actually look how to explicitly declare the types, so you can see over here if we hover over it, or you can highlight it and press Control K, Control I, so it shows us that the age is a number. So we can actually copy this part from the colon onwards and just paste that there, and you can see that now we've explicitly declared that this variable is a number. And if we do the same thing here with string, and we do the same thing here with Boolean. And now if we try doing is developer plus username, and we Well, let's actually take it something practical. Let's say we want to add 10 to an age. So really we want to do age plus 10 and say const new age is equal to age plus 10. And that would be a number implicitly. But let's say we made a mistake and we said is developer plus 10. So this already doesn't work because operator plus cannot be applied. And even if we say username plus 10, we would explicitly say that we want this to be a number beforehand, and it would obviously throw an error saying, listen, this gets typecasted to a string, and that's not okay. So we'd realize we have a bug, and we'd be able to do age plus 10. Cool. Moving on from that, we have slightly more complex types, like an array. So how would we actually type an array? So we want to say numbers is equal to an array of numbers. And there are actually two ways to type an array. You could either say number and then array with the square brackets, or if we copy this line down and say numbers 1, you can actually use the array constructor and number. And this is using something called generics behind the hood, which we'll get into in a later video. But both of these ways are valid. I personally prefer using the square brackets, but it's a matter of personal preference. Cool. Now let's talk about objects. So let's say we have an object called user, and the user has a name, Jacob. We have an age, which is 10, let's say, and we have is developer, which is equal to true. So if we want to actually type this, we just add a colon after the user, open up as if we're creating a new object, and I will say name is a string, age is a number, and is developer is equal to a boolean. But there's an issue with this, because let's say we want to create another user called user2, and this user's name is someone, their age is 100, and is developer is equal to false. So it's kind of annoying to have to copy this over and over again for each user object. So now we'll introduce something called an interface. An interface is just a way of defining a contract in terms of what a object will look like. So if we say interface user, so we'll say that all users have to have a name, and that name is a type string. They have to have an age, and that age is a type number. And they have to have an isDeveloper property, and that will be a boolean. And that way, if we can now erase all this and just put user instead. And let's do the same thing over here, colon, user. And that allows us, like we see, to reuse types. So moving on beyond this, let's say we have more complex types. Let's say, for example, we have a promise. So let's create a simple example of a promise. So result is equal to promise dot resolve to 10. So what do you think the type of result will be? Well, if we hover over it, we can see that it's a promise which resolves to a number. So let's just explicitly type that, promise, which resolves to a number. And that way, if we change this to hello, it is now not a promise which resolves to a number, in which case we'll get an issue. We can change that to string to fix this issue, and that now is correct. Okay, but what about something like a date? So we can say const date, it's of type date, and let's create a new date. Cool. Something to note here is that a lot of these things we're using explicit declarations, and for the most part you don't actually need to do that because Typescript already automatically infers the type. We could also get rid of this, and for the most part we just want to let Typescript do all the inferring as much as possible and do the least amount of typing. In a case like this with the user, so we want to make sure that the person actually abides by the user interface. So if they write cool, well, first of all, let's take off this user, right? So in this case, it happens to be correct. But over here, a person could write cool, true. And then these two objects are no longer conform to the same interface. So if we were to add the user interface back here, it would say that this is an invalid property and you got to get rid of it. And over here, let's just add that back in. Cool. Now, let's say we wanted to create a map between IDs and their users. So what we could do is say const map is equal to an object. But now let's say we want to say the map of ID1 is equal to user. Well, that doesn't work, and let's see if we can see why. So element implicitly has any type because expression of type 1 can't be used to index type object. So we have a map which is an empty object, and since TypeScript doesn't know that this is a valid key for it, we can't add it to the map. It's the same as if we were trying to go user2 dot something equals 10. That wouldn't work because this property something does not exist on type user. So the same thing here, 1 doesn't exist on this type, because this is the equivalent of saying that the type of map is equal to that, which doesn't allow for any properties to be added to it. So in order to actually accomplish that, we'll use a TypeScript helper type called a record. And a record is just a way of saying that this object will have unknown keys and values, but we will type the keys and values. So we're going to say a number is the key, and the value is going to be a user. And that way you can see that this now works. So we can say map2 is equal to user2. But if we try to say map3 is equal to hello, you'll see that that doesn't work because type string is not assignable to type user. And this is a really cool way how TypeScript basically allows us to explicitly say this is the type of things I want in my object, and don't let anything else in. And with JavaScript, I would have been able to do this no problem. Okay, and the last thing I want to show you is, well, if we don't want to use the map, if we don't want to recreate a map, we can use the built-in JavaScript map object. I'll just call this map1 is equal to new map, and we can just say map1 dot set 1 to user. Okay, this does work, but it's not very good. And the reason why it's not very good is because if I go to map1 dot set, I could say set hello to 4. Right, so this isn't typed very well. And if we hover over the map, over this map, we'll see that this is a map of any and any, which means that any variable or any type can go in here. And this isn't good because this is exactly what we're trying to avoid with JavaScript. We want to have everything explicitly typed. So the way we can do that is two ways. We can either say that this is going to be a map with key of number and a value of user, and you'll see that this now fails. Or we can just do it, let's get rid of that. Or we can do it over here. We could say that the key is a number and the value is a user. And this no longer works. Okay, so that'll be it for this video. And these are the basic types that you'll be using all the time. Interfaces are extremely useful. The basic types are also useful when we're using them in functions, which we haven't looked at yet. And in future videos, we'll look into more advanced topics as well as putting it all together in a real-world project. So I'm looking forward to continuing this series with you guys. If you want to get notified of future videos, make sure to subscribe, turn on the notifications, or comment if you want me to clarify anything. And I'll see you guys in the next video. Bye-bye.